Imagine this, okay? You wake up on a Saturday morning and boom, you've got this brilliant startup idea. Now, a few years ago, turning that single spark of inspiration into a fully working application, yeah, that would have required weeks, honestly, probably months of tedious planning, coding, debugging, and deployment. It was a total grind. But what if I told you that you could build an entire full stack application in a single weekend using AI? And no, I don't mean AI just magically writes every single thing for you while you sit back and sip coffee. I mean AI acting as your ultimate assistant, literally eliminating the boring parts so you can actually focus on solving real problems. In today's explainer, we're going over a complete step-by-step guide for developers learning AI integration. We are going to take a modern full-stack application all the way from an idea to reality.
But before we dive into the actual blueprint, we got to address the elephant in the room. There's this lingering question in the industry right now. Will AI replace developers? It's a super common fear, but we really need to dismantle this myth right off the bat. Listen, AI is not coming for your software engineering job. It's just not. What it is replacing is the repetitive, tedious work. The simple truth here is that the engineers who learn how to effectively work alongside AI are going to build faster, they're going to learn faster, and ultimately, they'll create vastly more value than ever before.
So honestly, asking if AI will replace developers is just the completely wrong question. The right question, the one that's actually going to skyrocket your career, is how can developers use AI to become more productive? That is exactly what we're answering today. We're going to reframe AI as this highly capable tool that handles all the heavy lifting of boilerplate coding. That way, you can focus your mental energy on the fun stuff, like architecture and real-world problem solving. All right, here is our roadmap for this explainer. We will start with Part 1, the AI force multiplier, then Part 2, blueprinting and database design, moving on to Part 3, building the full stack, Part 4, debugging, testing, deployment, and finally, Part 5, fundamentals still matter. Let's get right into it. So, kicking things off with Section 1, the AI force multiplier. To make this step-by-step guide super concrete, let's pretend we're building a task management SaaS platform. You know, a system where users can create accounts, manage their tasks, track progress, collaborate, the whole shebang. Now, most developers naturally just want to jump straight into the code, right? But that's a huge mistake. Step 1 is actually treating AI as your technical architect. You open up ChatGPT not to write a single line of code, but to generate a plan. You literally just ask it, hey, design a scalable architecture for a task management SaaS application. And within seconds, the AI helps you define your core features, user roles, database structure, and even your authentication strategy. By step 3, you're generating user stories and defining the exact scope of your minimum viable product. Instead of staring at a blank, blinking cursor, you instantly have a tightly focused roadmap that actively prevents feature creep.
Moving right along to Section 2, blueprinting and database design.
Okay, so with our requirements clearly outlined, we need to actually structure the data. You just ask the AI, generate a relational database schema for a task management platform. And wow, look at the sheer speed and output here. In mere seconds, it spits out a completely comprehensive schema. You get your tables for users, projects, tasks, and comments. But it doesn't stop there. It actually maps out the primary and foreign keys, establishes all the relationships between those tables, and even gives you index recommendations to make sure your database performs well under load. What used to take like an entire morning of whiteboard sketching is now perfectly laid out in moments. So the really crucial point here isn't just about speed, right? It's about strategy. AI acts as this incredible sounding board for you. It can frequently catch design issues before you've written a single line of code. For instance, maybe you just didn't consider that tasks strictly need project ownership tied to specific user roles. Well, the AI is highly likely to highlight that exact gap during the design phase. By catching those kinds of architectural flaws early on, the AI is saving you literally hours of frustrating refactoring down the line. It's a real game changer. All right, let's dive into Section 3, building the full stack. So we've got our roadmap, we've got our database blueprint, so it's time to build the backend. For a Java developer, this means spinning up Spring Boot, PostgreSQL, JWT authentication, and Docker. By integrating an AI assistant directly into your IDE, tools like Cursor AI or GitHub Copilot, you don't have to manually write standard architecture anymore. You just tell it what you need. You say, create a task entity with CRUD operations and validation. Bam. Instantly, you get massive amounts of boilerplate code generated right there for you.
The AI outputs your entity classes, your data transfer objects, repositories, services, and controllers. It builds out that entire underlying structure in a fraction of the time it used to take. But hey, let's pause here for a second, because we really need to establish the single most important warning of our entire step-by-step guide. The goal isn't to stop thinking. The goal is to eliminate repetitive typing. You absolutely cannot just blindly accept generated code. There is no magic button in software engineering, okay? You have to review everything the AI produces, but by letting the AI handle all the syntax and the boring boilerplate, you free up your brain to focus on the complex architecture and the actual business logic. For example, asking the AI to implement role-based access control, and then you carefully review how that integrates with your specific security standards. Okay, so once those backend APIs are humming along perfectly, we switch over to the front end. And whether you prefer React or Next.js, AI is incredibly proficient with modern front-end frameworks. You can literally prompt it to generate a responsive dashboard for a task management platform, and it rapidly builds out your navigation bars, dashboards, task cards, forms, and modals. You want a dark mode? Just ask the AI. Need drag-and-drop features, kind of like Trello? Ask the AI. It generates surprisingly clean code, turning what used to take days of constantly tweaking CSS and components into just a few hours of actual work. Now for everyone's favorite topic, Section 4, debugging, testing, deployment. Let's be real, debugging is historically the absolute most frustrating bottleneck of software development. It's where projects stall out and weekends are totally ruined. But this is exactly where AI transforms from a helpful assistant into an almost magical problem solver. Instead of losing 2 whole hours digging through 5-year-old Stack Overflow threads, you use this debugging prompt formula. You simply give the AI 3 things. Number 1, the exact error message. Number 2, the relevant snippet of code. And number 3, what the expected behavior actually was. You just ask, why is this happening? Whether it's a missing dependency, a classic null pointer exception, or some weird database relationship issue, modern AI tools can almost always pinpoint the exact root cause for you within seconds. And then, of course, there's testing. We all know it's absolutely vital, but manually writing out all the setup in the mocks, it's incredibly tedious. Well, the AI way looks a lot different. You simply highlight a service in your IDE and ask it to generate unit or integration tests. It instantly provides a comprehensive, super solid starting point. Now, you still need to review and refine them, obviously, but it dramatically improves your overall code quality while drastically reducing your development time. Finally, it's time to go live. Deployment used to be highly intimidating, especially for newer developers trying to figure it all out. But AI completely changes the game here, too. If you need a Docker file, the AI writes it. If you need a GitHub Actions pipeline for continuous integration, the AI generates it. If you need step-by-step instructions for deploying the whole thing on AWS, the AI maps it out completely. With just a few simple prompts, you can navigate the incredibly complex world of cloud deployment with total confidence. Which brings us to our final part, Section 5, Fundamentals Still Matter. We've seen how absolutely incredible these tools are all the way from planning to deployment, but we really have to understand the core overarching lesson here. AI is not a shortcut to becoming a software engineer. It's a force multiplier. The developers who deeply understand system architecture, relational databases, APIs, security, and system design, those are the people who will benefit the absolute most from these tools. AI doesn't remove the need for your engineering skills, guys. It amplifies them. It essentially gives you the output power of an entire team, but make no mistake, you still have to be the one steering the ship. We have covered a massive amount of ground today, walking through exactly how AI can take an application from a simple idea to a fully deployed reality in just a single weekend. So I want to leave you with this final thought and question to ponder. If you could build absolutely any application using AI today, what would it be? You've got the blueprint, you have the tools, and honestly, the barrier to entry has never been lower. It's time to start building. Thank you so much for joining me for this explainer, and I absolutely cannot wait to see what you create.